You're welcome to Maths 201 Introduction to Mathematical Method. We've talked about the domain and range of variables. Now we want to look at another aspect of the domain and range. Another aspect have been revealed to us, so we want to look at that quickly together. So, question number 3. Question 3. If we were asked to find the domain and range, domain and range of the function. Domain and range of the function w equals 9 minus x squared minus y squared divided by x. Did you see that? We want to find the domain and range of the function. W equals 9 minus x squared minus y squared over x. How do we solve the domain of this function? Alright, how do we solve the domain of this function? So this function has no problem except for the fact that x is here. The function has no problem except for the fact that x is here. And any number can satisfy this function except for the fact that if x is 0 here, there will be a problem. So imagine we have 9 minus 0 squared minus, let's say for example, y is 5 squared divided by 0. In your calculator, this is an error. 5 squared minus 0, for example. This is a problem. There is a problem here, right? No number sits on 0. There is a problem. 25, when you divide 25 by 0, you're going to be having maths error. And so we are avoiding error. So we say that the function, is defined. The function is defined if, you see that? The function is defined if x is not equals to 0. That's the only thing that makes that function make sense. As long as the x here is not equals to 0, right? So we said that the domain of the function, the domain w, is x, y, element of all real numbers squared. Why is it squared? Because the number of independent variable in the system is 2. So we have 2 independent. That tells us about the dimension. So x, y, element of all real numbers squared, such that x is not equal to 0. So this is the domain of the function. This is the domain of the function. So what will be the range of the function? What will be the range? What will be the range of the function? The range of the function w is all real numbers. All real numbers can satisfy this except for the fact that x must not be equal to 0. So the range of the function is all real numbers. What outputs can you generate? So whenever a range comes to our mind, output is what comes to our mind. So what comes to our mind in this function, any number can be generated from this function as an output, except for the fact that one of the inputs, which is x, should not be equal to 0. So we say all real numbers, both positive and negative. You can also write this as positive, negative infinity to positive infinity, the same thing. But this is not the same thing as all real numbers positive. This means, let me put it here, it's not the same thing. This means all positive real numbers starting from 0, 1, 2, as we approach positive infinity. So we now say that the range of the function is all real numbers. Okay. Domain of the function is all real numbers. The range, rather, the range of the function is all real numbers R. Again, we want to look at another question. You said find the domain and range of the domain and range find the domain and range of the function domain and range of the function f x comma y equals sine of 2x plus y, sine 2x plus y, right? The domain of this function. So whenever we're dealing with trigonometries, we have to treat the case dicey. It's a dicey scenario. Trigonometries, right? Trigonometries. So whatever you put as x and y here is valid. If you find sine 1 million, there's an answer to it. Sine 50 million, there's an answer to it. Sine 100, there's an answer to it. So whatever you put as a value of x and y, there's an answer to it. Sine of whatever you put there. In fact, if you find sine of minus 1 million, there's an answer to it. Any big number you put here, there's an answer to it. So whatever input you have for x and y is valid. Alright? So we said that the domain of this function is all real numbers. All real numbers. Or you can simply say x comma y element of all real numbers squared. That's valid. All real numbers. All real numbers. Right? So what will be the range of the function? What will be the range of the function? Now, this is where I come in. No matter the number you put in here, no matter the number you put, let's assume that everything here sum totals to 1 billion. Sine 1 billion, the answers to sine 1 billion, whatever it will be, it will be 0. Whatever, it will not be more than 1. Whatever you put in here, even if it's a negative, sine negative 1 billion, right? The answer you get here would not be less than minus 1. So the range of sine functions is minus 1 to 1. Minus 1 to 1. Did you see that? Very simple, right? Very, very, very simple. So all these things are the measure we use to define the domain and range. Let's look at one more example. Lane functions. So we said another law. Whenever you have a trigonometry, for example, sine, for sine functions, the domain has always been is a law. The domain of sine functions, every time you see a sine, whatever it is, the domain of that sine function is all real numbers. And then the range is from -1 to 1. For logarithm functions, for example, you have ln x plus y, right? And lane functions. So the domain of all logarithmic functions, now the domain of all logarithmic functions, not the range, the law, you should know this, the range of all logarithm functions is all real numbers. All real numbers. These are several laws that you should know. So let's look at another example. Let's look at another critical example. Very critical example. We said find the domain and range of the function. Find the domain and range of the function. Find the domain and range of the function. W equals ln x minus 1 over y. W equals ln x minus 1 over y. So we said, to solve this question, we said the function is defined. The function is defined when x minus 1 over y is greater than 0. So the problem that is facing the logarithms is that for lim functions, you must set the function greater than 0. Why? Because when you have ln 0, you have 1. ln 1, you have an answer. ln 2, you have an answer. You begin to have a problem when you say ln minus 1. There's a problem. So you know that domain is whatever makes the function defined. So we don't want to have a problem here. So that is why we said for all lim function, you must set the function to be greater than 0. Greater, not greater than or equal to, but greater than 0. All right? Greater than 0. So now, there is another condition that exists in this particular function. There's another condition that exists here. The condition is that y should not be 0, because if y is 0, you're going to have 1 over 0, and that is a problem. That is a very big problem. We don't want y to be 0, because if y is equals to 0, there is a problem. 1 divided by 0 is error. So another condition is that y should not be 0, as long as y should not be 0. So how do we write this? We said the domain W will be x comma y element of all real numbers squared such that x minus 1 over y should be greater than 0, and also union y should not be equals to 0. That's the domain of the function, and I hope that is clear. So these and many more are what we are going to be looking at in Maths 201. I would love to see you in the next class. All right.